All right, so now that you've got the notes on how to structure that diagram there, let me just walk through what we actually see here. And the example I'm going to use is coffee before an exam, right? Let's say I've got a hypothesis that coffee before an exam will help improve test scores, right? What I would do to test this is I would form two groups, two conditions, if you will. The top condition, as I said, is my experimental condition. The one below it is my control condition. And you can note this because there is an X that represents the manipulation in line with the top group and not with the bottom group, right? So essentially what I'm doing here is I'm going to give everybody the test. So O1 and O3, I'm going to give them the exam, right? Just normally. Everybody gets the same exam, both groups. After I randomly assign them, that's where the R comes in, right? Then next time I will give the experimental group a 20-ounce cup of coffee, have them drink it, and then give everybody the same exam again. And what I'm going to see is if the scores are different in O2 and O4, the post-test testing time is O2, O4, and what I'm going to try and see is how different the scores are in that post-test testing session. So as we look through this, when we go to assess this, if the random assignment worked, O1 and O3 should be approximately equal, right? Should be. That's what a randomization is all about. Should be approximately equal. However, if the experimental condition, if the manipulation in this case has a significant effect, we should see that in the comparison between O2 and O4. This is referred to as a pretest-posttest control group design because it includes both a pretest and posttest as well as a control group. This is an excellent manipulation check. This is an excellent study design and fairly straightforward. We're going to get a little more complex ones in a second. This next variation does not have a pretest, right? There are times, occasions, where giving a pretest will interfere too much with the results after the pretest, after the post-test rather. So what you want to do is not have a pretest post-test effect. So you're just going to randomly assign them, give the manipulation, and then give the assessment, O1 and O2 in this case. Right? Still a control group. So the above row is experimental, the bottom row is control. But in this case, we are not going to utilize a pretest. And this is based on the assumption that the random assignment that we utilize, the R is there, we're using random assignment, that the random assignment should create equality, relative equality between the two groups. All right? So that's the downside, is it's based on a solid assumption, but still an assumption, right? So it is possible that even if there's a difference in the post-test and that O1, O2, and if we see a difference there, we cannot be 100% certain that it's due to the manipulation. It might actually be down to the difference between the groups that we weren't even sure of when we first started stating it or started the research. So this is the problem. And as I said, it's useful when you cannot actually do a pretest for whatever reason. If a pretest is not possible, this is when you would use it. But ideally, you would use the previous one if the situation permits for a pretest. Okay, so this one's the Rolls Royce. This is the one that if you got all the time, all the money, and all the participants in the world, you run this one, the Salomon Four-Group. Right? And in fact, you could actually make more than 4 groups of it, but the base version is 4 groups, right? And if you look at it, essentially it is a combination of the pretest post-test and the post-test only, the last two ones we've gone through. So the pretest post-test is on top, rows 1 and 2. Post-test only is rows 3 and 4, right? And what this allows you to do, this allows you to test to see if the manipulation is working, if the exposure to the pretest is actually having an effect, and this third benefit is if time is having an effect, right? What if the power of suggestion is having an effect? That billboard there on the left. Billboards are incredibly effective in ways that most people don't realize because it's simply the power of suggestion. You don't even know that you've been manipulated, that your opinion has been swayed by the billboard until all of a sudden you're like, oh, we should really go to that restaurant, or oh, I should really stop by that store, or whatever, right? And this design allows you to, as I said, test for the manipulation. Does the manipulation have an effect? Does the pretest exposure have an effect? Does the suggestion of the research, so like a placebo effect, does that take place? And then number 4, finally, is there a temporal effect? Simply meaning the passage of time. I saw this play out in a study when I was an undergraduate research assistant. We were doing research on whether or not people would help other people. And we found that a lot of people wouldn't. But right in the middle of our study, 9/11 occurred. Right? And what we found is that as soon as we picked up data collection right after 9/11, everybody helped each other. right? This is what's referred to as a temporal effect, and in some cases actually referred to as a cohort effect. You don't need to know that, but I wanted you to be aware, because in this case, our results were not due to other factors, but they were due to 9/11. That reinforced the national identity, and everybody was coming together to try and help our fellow Americans in a difficult time, right? I hope everybody in this that is hearing this lecture can remember that. I don't know, some of you might be too young, and that makes me feel really old because I was a sophomore in college when it happened. So anyway, let's move on. So factorial designs, okay? Let me be clear before we talk about this. All of the designs I've just talked about were based on a single independent variable. All of the designs have a single independent variable. And the example I used was coffee, right? Coffee before an exam, okay? This one is going to involve two or more independent variables. So let's say there's, for example, an experienced therapist and an inexperienced therapist, right? And they're both administering two different types of treatment. They're both doing treatment A and treatment B. What we could do is see which treatment seems to be most effective with an experienced therapist and which treatment seems to be more effective with an inexperienced therapist. Basically, we're looking for an interaction between treatment type and level of experience in the therapist, right? And it forms this little Punnett square here, this little 4-box square, and it allows you to say, oh, well, what we see here is, in fact, an experienced therapist is going to be better with treatment B, but the next best option is an inexperienced therapist with treatment A. So it allows for very precise conclusions, and as I said, I've already used this term, but I'm going to reiterate it. It examines interaction effects. Do the independent variables interact with each other? Now let me go and throw it out there from a research and life perspective. The variables always interact. Always. Always, always, always. There is never just one thing that causes or affects something else. There is at least two things in every circumstance. And you can take that to the bank because it's true. So as we talked about, full experiments involve random assignment of the participants, right, and manipulation of the independent variable. It is possible to do select group designs that we've talked about here using a quasi-experimental design, right? In this case, there is no random assignment. Notice it says non-R at the beginning of each of these, right? Same designs we just looked at, but instead of randomization, random assignment, we have non-random assignment, okay? And that's fine. These designs will still be successful, but you have to keep in mind these are quasi-experimental. They are not full experiments, and you cannot be certain of any kind of causational factors when you run these, okay? Just to be clear. The crossover, okay? So let's say perhaps you're a therapist and you've got two different groups of clients. The top group is group 1. The bottom group there is group 2. People are randomly assigned. Notice the capital R at the beginning. They're randomly assigned either group 1 or group 2, right? And you're trying to decide if their treatment of depression, if you need to introduce therapy first or if you need to introduce medication first, okay? XA is therapy. XB is medication. And you'll notice the top row, the group 1, is getting tested first, therapy, tested again, antidepressants like pills, drug therapy, and then tested a third time, all right? By contrast, the second group is actually getting tested, receiving the pills, right? Then getting tested again, then receiving the treatment, and then getting tested a third time, okay? And what's essentially happening, you ready for this animation? Check this out. Bam, bam, right? What's essentially happening is the two groups are crossing over, right? One gets A first and then B, the other gets B and then A. So the treatment that they're receiving crosses over in the middle there. That's why this is a crossover design. It's usually at the midpoint. It can be at different points. Actually, you can get incredibly complex with this. I wouldn't recommend it. But this way, it allows you to establish order effects. Order effects are what you can discover here. Is it better to introduce the pills first and then the treatment? Or the treatment first and then the pills? Depending on what you're treating, the answer will vary. And this type of research design allows you to examine that. Multiple treatment counterbalance design. I'm not a fan. Okay, I'm not a fan at all. What you basically do is you throw all of the treatments to the client in a randomly selected order, right? So you might say, okay, well, I'm going to start with A, B, C, D. Not in this case. It's D, C, B, A, D for one person and C, B, A, D, D for another person, right? The problem is it doesn't allow you to rule out potential order effects, doesn't rule out interaction effects. It doesn't basically guarantee anything. What you're essentially doing is trying to find something that works very quickly. It's a little dangerous, not entirely ethical, very costly. I can't recommend it, just to be honest with you, especially from a research point of view. So some of the things that we might see, some of the issues we might see, order and sequence effects. We've already talked about this. Are you putting the horse behind the carriage or putting the horse before the carriage? Do you need to start the medication prior to starting the treatment? As we talked about in the crossover design, that is evident. We can find out if we need to use one before the other and the potential benefits of that. Okay? Variable restrictions too. Let's say, for example, I am treating one group with a antidepressant and the other group gets nothing. I might actually have the dosage too low for the antidepressant. If I'm giving them 50 milligrams, it might not do any good. Maybe they need 100 to feel any kind of effect. In that case, with a restricted variable, I'm actually not doing justice to the data, right? And then what's called a ceiling and a floor effect. Separate effects, by the way, separate effects, even though they're listed on the same bullet point. A ceiling effect is if I was to give an exam and everybody gets a 100. Or close to, almost everybody. Basically, everybody's hitting the ceiling with their scores. Was my exam effective? Probably not, because it didn't show any variability in the scores. Likewise, if I give an exam and everybody gets 5s, 10s, and 15s, I'm getting essentially a floor effect. Was the exam effective? No, because it didn't really assess their learning very well at all either. You see the same thing play out in research. Right? If you ask your client, on a scale from 1 to 10, how do you feel? And they're always saying 10, you need a better scale. Or need to be more clear about your scale. Right? That would be a ceiling effect. So things to consider. Let me throw them all in here once again with the transitions. You'd think I would just eliminate the transitions, but that's taking too much time. All right? So who are you going to include? Right? Why are you including those people? Is your sample representative? Right? How are you going to group them together? Are you going to group them together by condition? Are you going to use subgroups? Are you going to use stratified random sampling? Right? All things you want to consider. How many independent variables are you going to use? Let me throw this out there, especially for your thesis. Please use one. Don't use more than one. It gets very complex very quickly. And for your thesis, you want to do a good job with fairly simple research. Do not try and go too crafty with it. Okay? There will be a time for that. When you go to do your doctorate, be as crafty as you want to be, not during your thesis. Okay? Do I expect the interactions? That should have a question mark. Actually, it shouldn't, because it's a statement. Yes, you will have interactions. There's always more than one factor. I've already said it. I'm getting all fired up. How do I improve the validity? Bigger samples, better tests, more frequent assessment, sticking to protocols. We've talked about this quite a bit. Can I give multiple treatments? Yes, you can, but no, you shouldn't for your thesis. And if you are going to give multiple treatments, make sure you do it in a very strategic way. Can I use pretest? Once again, yes, I would recommend it in the real world. No, I wouldn't recommend it in your thesis. And who's going to pay for all this? That's hopefully not, well, I imagine it's a question in your dissertation, in your thesis, because you got to pay for the tuition or pay the student loans or whatever. But in the real world, research comes with a cost. Who's going to foot the cost of this, right? Do you have enough assets or resources to make sure that the study can be conducted with the design and the sample you have deliberately selected?